One of the things I like to do in my spare time is to watch math videos on YouTube. And one of the math videos I saw last summer and really admired was from 3 Blue, 1 Brown on his channel, where he gave a different and better derivation of the general quadratic formula. And not only is it shorter, it highlights some things about parabolas and the roots of parabolas that are very useful. And even though he's already done it there, he does some other and quite very worthwhile things in his video, but it's quite a bit longer than I planned this video on being. And so I thought I would share this to give the formula with wider dissemination. Well, I learned the general quadratic formula back when I was in high school, and we were so proud of having gone through it and gone through the derivation of the formula that we got a t-shirt, and we wore a t-shirt, and we actually went on a field trip and wore the t-shirt as a group, and so we were so proud of that. Because quite frankly, the derivation of the general quadratic formula was the hardest thing we had ever done in our lives. This derivation is much easier. I'm going to start out by drawing a graph of a parabola. I've shown a smiley parabola, as I like to call them. And as it crosses the axes, we've got two roots. We'll call them R and S. I'm following the notation of 3 blue, 1 brown here. And halfway between those two roots, by the symmetry of our parabola, that's the vertex. And we can have the midpoint here. And since it's the midpoint, the distance from the lower root to the midpoint and the distance from the upper root to the midpoint is the same. Let's label those distances as d. And so I can say that r is equal to m minus d and s is equal to m plus d. I also know that m is equal to the average of those two, m plus s over 2. Okay, so this is pretty cool so far. Now, what else do I know? Well, in terms of the equation, if I have my formula here, I can recover the formula for this parabola by saying that y is equal to x minus r, x minus s, okay? And I can put it into a form by multiplying these out. This would be x squared minus r plus s times x plus r times s. Now, notice that this is, when we go to get the roots, this is x squared minus r plus s x plus rs, and we would set it equal to 0. This formula looks different than this one. We don't have that a is a leading coefficient. We only have a leading coefficient of 1 here, but that's something that I can do very easily on this by dividing through everything by a. So let's not worry about that at this point. Now, this coefficient in the middle, okay, I can say that this is equal to negative 2m, right? Because r plus s over 2 is equal to m. This is a negative times r plus s, so this will be negative 2m times x. Now, that r times s, that's the product of the roots. So I'm going to let p be equal to r times s. So this will be equal to p here. And so this is all equal to 0. Now, okay, so I have this form of my equation. How can I solve for x? Well, my x is my roots r and s, and so I can have x is equal to m plus or minus d. What is d? Well, okay, here is where we can kind of get tricky. All right, I know that p is equal to r times s, which is equal to m minus d, m times m plus d. This is the difference of two squares. So this is m squared minus d squared. All right. Time to go to a clean sheet of paper. So p is equal to m squared minus d squared, and so d squared is equal to m squared minus p. So d is equal to the square root of m squared minus p. Again, I'm not doing the plus or minus there because I'm thinking of d as a distance, and I have my plus or minus taken into account m plus or minus d, so I can say x equals m plus or minus the square root of m squared minus p. Okay, so it's a simpler formula. Okay, I don't have fractions, and I hate fractions. The discriminant, we had the name for the b squared minus 4ac, that's the discriminant. This discriminant has a simpler form. And this is all at the price of just having a little different formula to our equations when we start out with. Now, let me start out with something simple. Okay, so I can show you how the wheels work on this. 2x squared plus 10x plus 12 equals 0. Well, this is not in the standard form. So what am I going to do? I'm going to divide through the whole equation by 2. That will give me x squared plus 5x plus 6 equals 0. If you're sharp, you recognize that you can factor this one, but we're not going to factor it. We're going to illustrate the formula. To get it in the standard form, which is x squared minus 2mx plus p equals 0, what I'll do is I'll say x squared minus 2 5/2, excuse me, and it would be minus 5/2 x plus 6 equals 0. So this gives me that my m is equal to negative 5/2. My d squared is equal to my m squared, which is negative 5 over 2 squared minus 6, which is 25 over 4 minus 6, which is 25 over 4 minus 24 over 4, which is 1/4. That means my d is equal to 1/2. And so my roots will be x negative 5 over 2 plus or minus 1/2. And so x equal negative 5 halves plus 1/2 is, okay, plus 1/2 is negative 4 halves, which is negative 2, and x equal negative 5 halves minus 1/2 is negative 6 halves, which is negative 3. And these, if you go through, these are the roots of that polynomial there. Okay. Now the question for old geezers like myself is, what about that old formula? Is it lost forever? Well, let's take a look. First, recall that the general quadratic formula is that. Now, how would I solve it using the new formula? Well, recall the new standard form. We would put our equation n is this. So in order to do this, divide through the original equation by a. Okay. And let's see, so I would do x squared at minus 2 negative b over 2a times x plus c over a equals 0. So I have m is negative 2b over 2a, and my p is equal to c over a. Okay, so my d squared is equal to m squared minus p, which is, okay, b squared over 4a squared. Okay, so minus p, well, that c over a will be what? A, okay, 4ac over, okay, 4a squared. All right, so this is b squared minus 4ac over 4a squared. D then is equal to the square root of b squared minus 4ac over 2a. My roots then are x is equal to, okay, m, that's negative b over 2a plus or minus, okay, the square root of b squared minus 4ac over 2a. And so as you can see, that this we can recover our original general quadratic formula from this. Okay, it's a nice connection to the past, certainly. We don't want to get rid of everything. We want to be able to read the old literature, and yet in handwritten work, the other is just so much easier to remember. It's so much easier to deal with. I think it's a good thing to bring in.